Okay, hyperbolas. I want to show you kind of the hyperbola and the ellipse difference. Okay. They're neither of them are circles, actually. Okay, that's the equation for an ellipse, right? We learned that last Thursday, or thought we did. Should have. Remember B, A, and C. Right? Those values are going to come into play again. So those values are going to be pretty much the same for a hyperbola. Okay? But the difference between an ellipse and a hyperbola graphically looks like this. So what can you do to an ellipse to make a hyperbola? Yeah, you cut it in half and switch things around, right? You just kind of face it out. So the equations are very similar in that respect. Bless you. What's the difference between the two equations?
The minus.
Yep.
Minus.
That's the only difference. One's added, they come together. One's subtracted, they diverge. Okay? So we can kind of compare and contrast the two to get an idea of how to build a hyperbola. Now, getting A, B, and C in these is very similar to an ellipse. C is the distance from the center to the focus, correct? All right, do you think it might be the same in a hyperbola? Yeah, mathematicians actually did something that makes sense. I know, right? Shut up. Never mind. I'm going to quit laughing like I think it's funny, because it's not. Anyways. Okay, A is the distance from the center to the vertex. What do you think A is? Right there. Okay. You guys are yawning like you're bored or something. Don't answer that. All right, here's where hyperbolas get a little bit different. Do you remember what these are called? Yeah. All right. So a hyperbola has a box or a rectangle that's defined by the vertices and the asymptotes. So you go vertical until you hit the asymptotes, and then horizontal. B is defined as this distance here. You can still kind of relate it to an ellipse, right? Okay, vocabulary. The long axis is called the transverse axis. That can go vertical. Okay, and this is called the conjugate axis. Okay, so the transverse axis always goes through them. It transverses the hyperbola. Do you want me to write down the equation for a vertical as well? Okay, so that's horizontal. Vertical, keeping in mind these are all going to shift. You know, it rotates 90 degrees. It's just like an ellipse. Okay. The A travels with the transverse axis, so this would be the Y value has A with it, so it's vertical. Right? Any questions so far? Okay. Here's an example. Write the equation of hyperbola with foci 7, 1, negative 3, 1 with transverse axis 8 units long. Is it vertical or horizontal? It is. You're right. So if you graph it, just for those of you that need a visual. 3, 6. There's 7, 1 and negative 3, 1. Okay, those are the foci. Where's the center? Okay, the foci in the center. The transverse axis is 8 units. What does that tell me? Four units on each side of the center. That's my 8-unit transverse axis. Okay. And if you want, you can. Okay, so what's the value of A?
4.
How do you know that? Yeah. Right there. That's A, so A is 4. Can we calculate C? Yep, because this is C. And all we need is B to write the equation.
Okay. Now this one's a touch different than ellipses, so you're going to have to write this on your blue sheets. I'm not going to ask you to memorize these, but we know this. B squared is C squared minus A squared. Okay. For ellipses, it was different. B squared is 9. Yeah. B is 3. Okay, so we can write our equation now based on the horizontal. What's our center? 2, 1. Right, so we have x minus 2 over a squared, so 16, minus y minus 1 squared over b squared. There's your equation. Okay. How are we doing? What? Oh, the transverse axis is 8 units. You're told that. Okay, that's over 4 and over 4. Yeah, it's 8 units long. So it's 4 units each side of the center. Yep. The transverse axis is 2 times A, if that makes it easier. Okay, so A is 4. Any other questions? Please ask them so you don't just bonk like you did with ellipses. Anybody? It was easy now, isn't it? And then when you get to the homework, you bonk. Pretty much. Okay, let me see if there's anything else that I want you to understand. 2.
Why did they do it in triangle in the lesson?
What?
Why did they do it as a triangle?
Which one? Where are you looking at? Page
24 and 643.
643. That is the proof on how to calculate the standard form of an equation. I wouldn't worry about it. That's why I'm not showing it to you. Okay. One more thing, and then we'll be good. This hyperbola might look something like that. The question is, what might the equations of the asymptotes be? Okay. Those will actually define where these go, right? So on this one here, they're just more equations to use. They are more equations. So the horizontal that's the equation of the asymptote. All right. This is point slope form. You guys have seen point slope, right? Well, I guess we'll find out. Okay, what's K? Yeah, on here. K and H come from the center. Well, it's 1. B is 3. A is 4. And X minus 2. You have 2 different equations because you have 2 lines. The only difference is the slope. It differs by a negative. Okay. Do you want me to simplify this? Or can you use it in that form? Okay, because there are 2 of them. Yep. So if I wanted to graph it, I would probably split it into 2 different ones and put it in slope-intercept like we're used to. Okay. That's everything. So all the questions I'm asking you to complete are write the equation, find the coordinates of the center, the foci, and the vertices and the asymptotes. Okay. That's all I'm asking you to do. Can you handle that? Okay, well, you have over 10 minutes here, so try to get some of the work done. There's not very much. Yeah, you should come to my other room. Probably 10 to 15 degrees colder in the shop, wouldn't you say, Jared?
Yeah.
Pretty easily.
57 and 55, 57.
51.
Oh.
My 7s have a line through them, but not that you need to remember that. Logical deduction would dictate that that is 51.
Well, a logical argument.
I wonder.